Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's episode. Thank you for joining me. I've got 3 case studies for you today. First one is a 2015 Chevrolet Impala that's having some battery plausibility codes set in the BCM. The second vehicle is a 2005 Buick Lacrosse, where the instrument cluster is being replaced with a used unit, and my challenge is to adjust the mileage in the cluster that's going into the vehicle. The third vehicle is 2005 Nissan Altima that is a crank no start, but has several different issues that I've got to work through. So I found all 3 of these vehicles pretty interesting, learned something from all of them, and hopefully you'll find the same thing. Before we get going with today's episode, I just want to mention, I've said it a few other times on the podcast before, I recently became a distributor for Top Don Tools. So if you are considering any of those scan tools, give me a call and I could definitely get you the podcast hookup. The reason I decided to jump into this, I'm not really necessarily looking to get into selling tools as my main gig, but I kept going to shops, and of course, I'm doing the scan tool thing, the programming thing, and everybody here is asking me, well, what scan tool should I buy? What scan tool should I buy? And of course, that's a tough question to answer because it all depends on your goals, what you're trying to accomplish in your shop, what type of vehicles you're seeing, and what type of work you want to get done, right? And of course, usually the easiest answer is just buy all the scan tools and then you'll be fine. Because the issue is that no one tool is going to do it all, right? That's the thing, is no matter what you buy, there's going to be holes. There's going to be things that don't work the way that you want it to, or just doesn't have that option at all. But then that tool will also have some strengths, some things that it does really well, efficiently, fast, right? And so, a lot of research goes into this. If you're going to buy a tool, you really need to know what your goals are as a technician or as a shop. So anyways, I can try and help shops out with that. But I have found in my personal use that using the Top Don scan tools, they are very effective, especially for the price point, right? For what you're paying and what you get, they do a really good job. The other thing is that they're really fast. And that's the thing. I've been talking with shops. I've sold a few of these scan tools to the local shops, and they're like, wow, this thing, blasts through the full vehicle scan, right? Gets through all the modules, has a cool topology map, and you can generate a report and email it. And it's all very, just a slick process, right? And they're very capable tools, right? Cover domestic, Asian, European stuff pretty well. Again, hey, no tool is going to do everything, but I like these things for what they can do. And again, the price point. So if you're interested, they got all kinds of different options, many different levels of scanner, depending on what you're shooting for. They got ADAS stuff. They're working on remote diagnostics and programming, battery chargers, maintenance reset. They got all that stuff. So shoot me an email or a message on Facebook if you're interested, and we can talk tools, we can talk prices, we'll get you hooked up. So with that out of the way, let's jump into the episode. First vehicle, again, 2015 Chevy Impala with a 3.6 liter. The shop called me when he was on the phone. He said, hey, this thing's having some random electrical issues and there's lights that are flashing. And I wasn't sure exactly which lights he was talking about, but I figured, okay, I'll get to the vehicle. I'll go over it with him in a little bit more detail and we can figure out what we're after. So I set it up on my schedule. I get there, come look at the vehicle, and I'm talking to the guy about it. Hey, kind of what exactly are we after? What are we trying to solve here? And he told me again that the customer complained of random electrical issues. Sounded like the interior lights were flickering at one point or another, and there were some dash lights on. He wasn't exactly sure which ones. he did mention to me that they did their basic checks and they did find that the battery failed the load test. So before I got there, he put a brand new battery in this. And he told me, he's like, I think I might have fixed some of the issues because I don't see the lights flickering. I don't see all the same issues that the customer is talking about. Of course, I don't know, is this intermittent stuff? What's the deal? But he did mention, okay, I put a new battery in it. It seems to be better than it was. All right. So what do you want me to look at? Of course, was my question. I don't want to chase an intermittent issue. But he's like, well, what I want you to go after right now is there's a code that's setting in the body control module that we're concerned about. And it keeps resetting. You clear it and it will come right back. And it has to do with battery voltage in the system. Okay. So at least I have a goal. I have something to shoot for, right? I don't want to just be just randomly poking at stuff, trying to go after symptoms that I'm not even sure about. If I got a code, that's good for me, especially if it's hard fault, it keeps resetting. I like that because I can just, this is my goal, is to get rid of this code, get this code out of the BCM. So scan the vehicle and I do find this code in the body control module. It is a B1517-5A. And I want to note that those first 5 characters, right? The B1517, that's our classic OBD2 format, the B meaning body, and then the 1517 correlating to a particular area of the vehicle. But there's also a subcode, which is 5A. And we're going to talk about that, but pay attention to these subcodes. I'm going to bring that up again. Pay attention to the subcodes that are in addition to our classic OBD format. I'm seeing these more and more on more vehicles, and they are really important to actually put that into your code search when you're looking up the codes. It makes a big difference. Okay. So anyways, there is a definition for this code in the scan tool. It says battery plausibility failure. Okay. And that's it. That's all it says in the BCM. Now this code will reset. I did notice the engine had to be running in order for this code to reset, but you clear it, give it 30 seconds, code comes back in there. All right. So again, hard fault. I like that. I did do a quick check of the system voltage, that the scan tool has a little voltage readout at the top. It was somewhere 13.8 to 14, somewhere in there, fluctuating. Okay, so at least it's charging, right? And again, this is happening while the vehicle's running. If you do key on, engine off, it didn't seem to set the code, but running it would. And again, voltage just at a glance seems to be okay based off of the OBD2 port. All right, but code keeps setting. So now I need to figure out exactly what this code's referring to. So I go into service info and I was able to find the B1517. It didn't list any subcodes. And I checked a couple different service information systems. Now I am using aftermarket service information. So maybe GM's factory service information had more, but for both AllData and Identifix, the only thing I could find was this B1517, and they grouped the code in with literally 25 other battery voltage codes. Okay. So, and I'm not exaggerating there. There were 25 other battery voltage or system voltage type codes. And these are completely different codes. This isn't just the subcode. This is the entire code is different, and they just group it in there. And what I'm referring to is when we look up a trouble code, I want to know exactly what's causing this code. What's the definition? Usually GM's really good. They'll give you a system description operation. They'll say exactly, what fails in order for this code to set. When is the computer looking, monitoring the system in order to set this code, and what are the, the enable criteria, the prerequisites, in order for the monitor to run. All that stuff is usually in there. And it did have a section, but again, it grouped all of these voltage style codes into one very short description. And all it told me was that the control module, and it did say control module or sensor detects that system voltage is less than 9 volts or more than 16 volts for 5 seconds. And I think it did mention that the engine had to be running in that case as well, but that's all it said. Now, again, when I was looking at the voltage in the system, I saw that it was running 13.8 to 14, somewhere in there. So we're in our threshold, at least what the system voltage is. And in this code information for this B1517 grouped with all the other codes, it doesn't say anything else, and there's no subcodes. So I'm thinking about that. I'm like, I wonder what the 5A means specifically. The other thing that kind of just, it stuck in my mind that, hey, this is weird about this is that it said nothing in this description of the code about a battery plausibility failure. It actually listed it as a system voltage error or system voltage issue. Didn't say anything about a plausibility, right? And I'm thinking plausibility as either the control module has determined that a voltage is irrational based on what it's programmed with, or it's doing a comparison, right? A lot of the plausibility things that we see is a comparison between 2 points or a rationality style code, right? One that comes to mind is if you have a series of temperature sensors on a vehicle for an engine control module, right? You have intake air temp, you have transmission fluid temp, you have engine coolant temp. When you start up the vehicle after it's been sitting for a period of time, the computer does a rationality check and it expects all those temperature sensors to be within the same range. And if it sees, 2 of them are at 80 degrees and one's at -40, okay, this is a plausibility or rationality style code. So that's kind of what I'm thinking when I read the description in the scan tool, but it really doesn't point to anything on that in the description of the code. It just says the voltage is below 9 or above 16 while the engine's running. Okay, so at this point, I don't really have anything more to go with in service information. I did do some searching just to see, can I find that 5A? Is there anything more that I should be looking at in particular? Couldn't find anything. Well, let's just go through it and see what we can find looking at the vehicle. So I go into the body control module and I want to pull up as many data PIDs as I can as far as the system voltage goes. And it has a whole section in the BCM. If you go into the scan tool, it breaks down the data PIDs into different areas of the vehicle that the body control module is involved with or controls. One of those is electrical and charging. And I go through there and everything appears at first glance to be accurate, to be where it needs to be, right? The voltage data PID reads the same as the system voltage in the scan tool, and no other data PIDs as far as the electrical system seem to be out of place at first glance. I don't notice anything that's really out of whack here. And I did take the time to actually put a meter on the battery itself to make sure, okay, we are charging accurately. And I don't see anything that's really out of place. I don't see where the BCM could be seeing something below 9 or above 16. The system is definitely not below 9 or 16. Really just don't find anything that stands out right away. So I'm doing some thinking. I'm like, where am I going to go with this? What's my next step here? Because as far as I can tell, nothing's really standing out. I did check to see if there's any service bulletins, maybe an update on the BCM that would, maybe this is some sort of software error, right? That's corrected with a reprogramming of the control module. Didn't find anything on that. And I kept coming back to the subcode, right? I've kind of been a stickler on that stuff lately because this subcode, the 2 digits after the main code, I have found can really change the whole definition of a particular code. Fords seem to be doing this a lot lately, or at least I run into it on Fords a lot, where it will have one code, but you have to look at the subcode because it completely changes what you're going after or what the fault is pertaining to. And my goal is to figure out exactly what the computer is looking at, why it's unhappy, and why it's setting this code. So I need to know about the subcode. And I did more checks. I looked again just to see, am I searching this wrong? I tried a couple years earlier and later to see maybe the information would change. It was pretty much the same thing. What I ended up actually finding here was Google helped me out here. So I just typed in B1517-5A into Google. There was a post on diag.net. Didn't necessarily give me the information I was looking for, but did point to some stuff with a body control module and some grounds that had failed on a particular vehicle. But about halfway down the first search page on Google, this was like just one of those generic websites that's like dtcinfo.com or something like that. Well, pulled up with my exact code with the subcode for a Pontiac. Didn't even really specify what year, but it had my subcode in there. And it actually had some information about the code that was different than what I saw in the service information just for B1517. So this is what it said in the Google document. You got to be careful with Google, but in this case, it definitely pointed me towards doing the correct checks. It says that the voltage of the 2 BCM battery sense circuit differ by 2 volts for 10 seconds or more. Okay. Now I have something to go for, because this makes a lot more sense than above 9 or below 16, right? I'm not seeing anything that refers to that, but that the BCM has 2 different sense circuits, right? It didn't mention anything about that in the service information where I found it. Maybe if I went to the description operation of the BCM, maybe I would have found that, but I did not read that at this point. But in this code on Google, it says the 2 different BCM sense circuits are going to be a difference of 2 volts or more for 10 seconds, right? So this is something that I can actually go check. And I pulled up the diagram for the BCM to see, okay, where are these sense circuits? I would recommend for doing something like this, use the OE diagram. They lay out powers, grounds, and communication all on one page. So you see all of the power feeds and ground feeds and the communication lines as well. I'm not too concerned about those right at the moment, but for GM diagrams, it'll have all of the power and ground feeds to a module, so you don't have to go through 4 or 5 different pages like the redrawn. So I pull up the OE diagram, and this BCM actually has 9 different power feeds to it. Now, it doesn't list which ones are the sense circuits, but you know what? If I go to the BCM, I can just check all of these, and I just want to make sure that they're all the same voltage. That's it. Pretty simple. Now the BCM in this one's located under the dash on the driver's side. You can pull open a little panel just left of the steering wheel, and you'll see a fuse box in there. This fuse box, there's a couple of retainers. You can snap that, and you can move this fuse box kind of to the side, and the BCM is located right behind it, and you have access to all of the, I think there was six or 7 connectors on the BCM. And it's very easy just to get your test light or measuring tool right in there and check all of these powers and grounds. Very, very simple to do. So I started with the grounds, make sure those were good. The way that I'm doing this is I'm leaving the BCM plugged in. I'm going to connect the test light, and I'll switch it to power or ground depending on if I'm checking a power or ground. If I'm checking a ground, my test light's going to be powered up. If I'm checking a power, my test light's going to be grounded. And the way that I do this is I have some retractable leads that they spool up, and I clip those right to the battery. And then I'm going to bring those leads to me, and I'm going to use those for my test light. And so I'm going to touch the terminal. Let's say I'm going for a ground. I'm going to power up my test light. I'm going to touch the terminal that has the ground wire going to it. So I've got my test light connected, and what I want to see is that my test light lights up, right? Now, a visual confirmation of a test light lighting up it's something, right? I know that I do have a ground feed. Now, in this case, this particular code, I need to know a little bit more than just, is the ground present? And it said in the code information that we're just talking about a difference of 2 volts. You may or may not be able to identify 2 volts just by looking at a test light. Maybe you know your test light really well and you can do that. I'm not 100% sure. So what I'm going to do here is I'm going to actually add in my voltmeter lead. Okay. And what I'm really doing with the voltmeter at this point is I'm just going to do a voltage drop test along with connecting my test light, right? So I've got my test light just back probed into the ground terminal. And then I've got my voltmeter, which is going to be connected to battery ground through those little clips. And then I'm going to touch it right there. And I just want to make sure there's no voltage drop on these grounds. And they come out with minimal, small amount of millivolts there, no significant voltage drops on the ground, right? So I know it lights a test light while connected to the module, right? The circuit's loaded because it's connected to the module. I'm giving it an additional load with a test light. If this was disconnected, I'd probably use a headlight bulb, but because the module is plugged in, and the car's running while I'm doing this, that circuit is loaded, right? Assuming that it's connected, assuming that it lights the test light, which it does, that circuit's already loaded, and I'm checking it for voltage drop at the same time. So kind of killing two birds with one stone. You don't have to do it this way. It's just the way that I chose to check to make sure, okay, we got a ground there and we have no voltage drop to that particular ground. Awesome. So boom, boom. There was 2 grounds on this. Pretty easy to check. But we have 9 power feeds into this, and I don't know which ones are the sense circuits that it's referring to. So I go through these, and I'm going to flip-flop some stuff, right? I'm going to ground my test light now, and I'm going to switch my lead for my voltmeter to the positive side of the battery, and I'm still going to be touching it to there to see, okay, is there any voltage drop? So I go through these, again, very, very small amounts, millivolts, negligible amounts of voltage drop, normal that you would see, right? You get a little bit of voltage drop in every circuit, but nothing that is concerning, right? So I finally get to one of the connectors that's a little higher up on the BCM, and I find that I have 1.5 volts of voltage drop on this circuit. And I check another circuit and I have the same thing. So 2 out of the 9, I've got 1.5 volts of voltage drop between the positive battery post and the voltage feed that's going into the BCM. And I also did find if I mess with some of the electrical in the vehicle, if I turn the headlights on, the rear defrost, this voltage drop would actually increase more. It would go up higher. And if I reduce the electrical load, it would go down more. So we've definitely got a voltage drop issue going on here. Now, again, this is where the diagram really helps the OE1. I looked, and again, I mentioned there's 9 positive battery feeds into the BCM. The 2 circuits that had voltage drop, you can see on the diagram that they come from the same source within the underhood fuse box, right? So it's going to show you powers are going to be at the top of GM diagrams, and there's a series of fuses that it shows, okay, power's coming, from these fuses going into the BCM, but above those fuses, it labels, okay, hot in run or start, hot all the time, B plus, whatever. The 2 that had the voltage drop on them come from the same source within the underhood fuse block. And there are 2 fuses that are connected to those circuits. So that's where I'm going next, right? I'm going to go right to the underhood fuse box, which is right next to the battery. And now I'm just going to do a voltage drop check between the positive battery post and these fuses in the underhood fuse block. And I do that. So I'm just connecting my voltmeter across, and I've got the same amount of voltage drop. Okay. So right at the positive battery post. Now there is a fuse panel that's on top of the battery, and it's got these flat style fuses that are bolted down, not the ones that you can just remove by pulling. This is outside of the underhood fuse blocks. This is just like its own little unit that's on top of the battery. So that was my next check. So I moved over there, and I want to make sure that none of those fuses had voltage drop, because those kind of fuses would be very vulnerable to that, the way that they're set up. And I've seen, some of them get heated up where you start to get some voltage drop there. There actually wasn't any there. What I ended up finding out was the voltage drop was inside of the underhood fuse panel. So by moving my meter around, by going to the fuses that fed these 2 circuits to the BCM, I was able to measure the voltage drop was inside of that fuse block, underneath the hood on the driver's side, right next to the battery. And so one more verification to do this, what I do is I just jump power from, a known good source without the voltage drop to this circuit that's going into the BCM, and I could connect it to the fuse. I could do it right at the BCM where it was easiest. And then I clear my code, and I just want to see if it comes back, right? And I did that, and the code didn't come back. And I waited about 5 minutes. It didn't come back. I remove that jumper, and the code comes back right away. Okay, so I know this is my issue. I know that the BCM is seeing a difference between 2 of its voltage sense circuits. So this thing needs a underhood fuse block, and it'll take care of the issue on this Chevy Impala. So just a little bit of voltage drop work there. It's important to understand, how voltage drop works. To be honest, I don't use voltage drop every single day. Some people really, really preach it. I have a variety of different ways that I like testing circuits, but in a case like this, It's actually really beneficial to understand voltage drop, and you can identify exactly where the issue is if you understand how to utilize it. So important skill to have, and just an example of where it proved out the failed component for me. All right, on to the next one. This is a 2005 Buick Lacrosse. I actually helped with the diagnostic on this one, which wasn't anything too special. The dash was dropping out. Basically, the whole dash would go dead. The shop had suspected it was a communication issue or network issue with this thing. It's a class 2 single wire. And I got into it. I helped them diagnose that it was actually the cluster, because we could get the cluster to fail and the network's still alive. The cluster was the only thing that I couldn't talk to. Powers and grounds were good. We actually pulled the back panel off of the cluster, and I could flex the circuit board and get it to come in and come out. And so they just wanted to get a used unit for this thing. Now, here's the thing about this Buick Lacrosse, and it's a '05 Lacrosse with a 3.8 liter, the old 3800 engine, one of my favorites. It only had 17,000 miles on the vehicle. So this is an old guy who owned this thing and obviously has barely ever driven it. I mean, this is like a brand new vehicle. I got a little excited, like, oh, dang, a 3800 with only 17,000 on it. That's a nice vehicle. And so when he gets the new cluster in this thing, he wants the mileage to reflect that. And they're going used. Honestly, I didn't even ask why, if the new one was not available, or they're just trying to save money. I don't know. That's not my thing, unless it really makes my life difficult, but they wanted to go used, right? And so on these particular Buicks, and a lot of them from this era, some of the earlier 2000 GM vehicles, the mileage for the vehicle is actually stored in the cluster itself, right? So if you take a cluster out of a vehicle and you put a new one in, the mileage is going to be reflected from the vehicle that it came out of, okay? And so he does a search, and there's lots of these clusters out there used, but the mileages are all fairly high. And in fact, the lowest one that he could find was 97,000 miles, which in most cases for an '05 is probably going to drop your mileage as opposed to raising it. But in this case, we're getting 80,000 more miles. The guy doesn't want that on there. He wants the mileage to reflect the actual mileage on the vehicle because it's so low, right? And I get that. I understand it. So anyways, that's just the setup to this one. My goal now is to figure out, can I change the mileage in this cluster? I couldn't find any tools that would plug in and do this. There's some Chinese market tools out there where you can plug into certain vehicles and adjust the mileage. There's other tools out there that can do it through the OBD2 port. Did not seem to be an option for this one. So the next thing that I'm thinking about is maybe this is something where it's a board level job, right? So the mileage is in there. It's in the cluster somewhere on the circuit board, stored in some sort of memory device. And it might be a matter of just either swapping or writing the mileage to correct it. But I did some research. I looked around, talked to some people, couldn't find anything on this specific application. There's a lot of other Buicks, a lot of cars around this year that they had some information on, but nothing specifically for what I was working on. So I told the guy, I was like, well, get me the used cluster, get me the original cluster. I'll take them home. I'll see what I can do. No promises, but I'll give it my best shot. Cause I've done some of this EPROM and board level work now, and learning more every single time, but sometimes I don't know whether or not I can actually get the job done or not. So this is going to be an experiment, and my plan is I'm going to get these. I'll take the old one, the original one, and I'm going to try and take the circuit board out of the cluster, which is it requires a little bit of disassembly. There's a back panel you pop off, pretty easy. A front panel, you have to take the needles off for all the gauges, which you do want to be careful about because these can be put on incorrectly. You could also damage the stepper motors if you take them out incorrectly. But so take those off, and now I just have a circuit board in my hands, right? It's an instrument cluster. Many of you have seen these apart. It's just a circuit board with lots of different components on there: LEDs, resistors, stepper motors, processors, memory devices, drivers, all that stuff, right? And what I'm hoping to find is an EEPROM, so an 8-legged EEPROM, little chip on this thing that would potentially store the mileage for this cluster, right? Because we know I know that the mileage is stored in the cluster, and we verified this when he got the new one. We plugged it in, and it read 97,000 miles. So it's definitely stored on that board somewhere, right? The mileage is in there. It's just going to be a matter of finding it. So I search the board and I find no EEPROM devices, nothing that even looks like an EEPROM. And again, the traditional EEPROM is a little 8-leg chip. There are some different varieties and different ways that these can look, but for the most part, they're going to be similar. This little 8-leg chip, and you can identify it. There's a number on it, so you can tell what type of EEPROM it is. And then it's just a matter of either connecting to it on the board or potentially removing it, reading it, or you could even swap the two chips between the cluster. But I don't find anything on here. There's some other chips on the board, but they don't appear to be EEPROM or memory storage devices. Not exactly sure what they are. They don't seem to be devices that are going to store mileage. There was a big processor on the board, right? And just about every computer board is going to have some type of processor. It's the component that is making the decisions and running the computer functions. There is a big processor on this board, and it has a label on it. It was a Freescale MC9S12H128. So if you're like, well, I don't care what the number is, if you run into one of these, you'll need to know the number of the processor. But this is the only thing that I find on here. Now, talking to some friends who know way more about this stuff than I do, they recommended or suggested that the mileage is most likely going to be stored within this processor because the very knowledgeable people that I was talking to said that this particular processor has an emulated EEPROM within it, meaning that there's a section inside of this processor that's able to store data just like an EEPROM device would, right? So that little 8-legged chip, it's inside of this thing, not a physical chip, but the information that I'm looking for, what I want to change, is inside of this processor. Okay, so how do I access this? How do I change this? How do I read this? Well, having that number that's on the front of the processor, I'm able to do some research on it, right? You can look up data sheets online, or you can use some of the tooling that you have to see if you have a connection diagram or pinout for this particular processor in order to connect to it and read and write. And there's lots of different programmers out there that will do this. But one of my favorites that I've been using recently is the Autel IM608. Now I use this as a scan tool. I use it for the immobilizer functions, but the programmer that it comes with, honestly, I've been super impressed with what it can do. People kind of give, the Autel some crap, especially the IM608 for its capabilities. But man, I gotta say, I've been extremely impressed with this tool and what its capabilities are. I mean, what you get with the 608 package, with the programmer, with the JBox, with the scan tool itself, I mean, it is a really powerful combination of tools that I think most people are probably underutilizing. I know I have been, because I keep finding more and more things that this thing can actually do. Well, Autel, if you go through the list of components in the scan tool, this processor is listed, right? And you have to look it up. You have to say, okay, this is a Freescale component, which there's a logo on the chip, so you can tell that. And then you go through the actual numbers, and that's why I listed off the number to you for this processor. Well, I ended up finding it in the list in this Autel. So it has it listed there, and it will also provide you with a connection diagram. Say, hey, here's where on this chip that you got to connect to in order to read or write. But it's listed, so maybe it can do it, and I would be careful, because just because a tool lists something doesn't always mean that it can do it. There's always that potential that it's listed, but it's not actually going to function. But it's in here. I have a connection diagram, so I'm gonna give this a try. Now, the diagram that you have for this is not a picture of the circuit board. It's not, hey, this is a '05 Buick Lacrosse cluster. And I looked for it that way, because you can look up certain components by the actual module that you're working with, this was not that case. I'm just looking up the processor. And so you get a picture of the processor with all its legs, and then it points to the legs and say, hey, connect to this one. So you find pin 1, and you're going to count over until you find this one was pin 50 through 54 needed to be connected to. Now, there's 4 connections that I have to make to this processor. Actually 5, but 2 of the pins are together, so you can just make 4 connections. This processor has 144 legs on it. So if you've ever seen one of these little black chips on a board, it's got 144 little tiny legs on this thing, and it's pointing to 4 of them that are all close together, and I'm supposed to connect to them. So this is where this can be kind of challenging to do. Now, I've got some options here. I can try and remove this processor and put it onto a board that comes with the Autel and then connect it to the program and read it that way. I could, if I felt confident enough, just swap these processors over and be done with it. I'm not entirely confident with my skills yet. I can do an 8-leg EEPROM, no problem, but 144 leg processor, getting that desoldered and then back on and having all 144 legs go back, soldered correctly on the board. I'm not feeling 100% confident with that. And so what I actually ended up doing was I wanted to attempt to remove this processor and put it onto one of there's like a little, it looks like a circuit board, and it has all the connections for one of these processors, and you desolder it, which actually that can be the easier portion. Is just desoldering this thing off of the board. You could put a heat gun on it and you just sort of poke it until it moves, and then you put it onto the other board, solder to that, and then it's an easy connection to your programmer. Well, okay, so I do this, and in the process of removing this processor from the old board, I end up bending a few of the legs on this thing. And again, to be expected, I'm not by any means an expert on this stuff yet. I'm learning all the time. I need to practice more, but that made me nervous to swap it with the other one, because I'm like, okay, I don't want to damage the new cluster in any way, right? And I'm not feeling 100% confident in my skills to do this swap yet. So what I decided to do was connect this thing up to the board, which is what I did, and I kind of bent out some of the legs, and I soldered it to the circuit board best that I could. And I focused on making sure that no legs were bridged over, that there wasn't solder, bridging 2 contacts together. And it's kind of meticulous work to get this to happen. But I really focused on those 5 pins that the diagram had to make sure, okay, these ones are definitely soldered and nothing else is touching each other. And now I'm going to give this a try. I'm going to connect to it, see if it works, right? I may have kind of screwed myself over here by removing it, but that's the route that I decided to go. And I was actually able to get a read, surprisingly enough, connected to my programmer using the diagram and the tool. I was able to read the EEPROM section in this processor. All right, cool. But now what am I going to do with that? Do I remove the processor from the new module? I don't know that I necessarily want to do that, because again, I kind of bent up some of the legs, and I don't want to wreck this control module, because honestly, the original processor, which I was able to read, I don't know that I could get it back on a board and have all of the legs connected the way that they're supposed to. I'm not sure that that's going to be successful. I did get the data out of it that I wanted, but again, I'm not feeling real confident. So this is probably what I should have done to start. This is definitely what I should have done to start with. But hey, we learn through doing, or at least that's me anyways. I think, okay, I want to try to connect to this processor while it is still on the board, still in circuit. And again, I did have a friend that was helping me out that said, yes, I usually read these things in circuit because they're used in other applications. So how am I going to do this? Now, again, imagine this 144 leg chip is soldered to the circuit board. And of course, all the terminals I have are right next to each other. Soldering directly to them is going to be very, very difficult. I have a setup called PC Byte, which has little arms that have push pins, and you can connect to the circuit that way. But even those, I don't have enough room to get all four next to each other because these pins are in a very small proximity of one another next to each other on the processor. Okay, so how else am I going to do this? Here's what I decided to do. And this, again, was meticulous. It was a lot of work, but I found the pin that I needed. So let's just say pin 54 on this particular processor. I connected my ohm meter to that leg, and then I poked around on the board and other parts of the circuit board away from the processor, not too far away, but away from the processor. And I waited till I heard that beep, right? I had it set on continuity, so it beeps when I have a connection. And when I found a point that I could easily connect to, whether it's solder or with PC Byte, I marked that. I took a picture, said, okay, this is connected to pin 54. And I did that with all 5 of my terminals that I needed to connect to. There was a ground, there was a power, or 2 powers, but they're linked together, a reset, and then a transmit receive, right? And so it took a while, but I was able to map this board out and find the connection points away from the module. Easy access, easy connection, as long as you know where they're at, right? That's the key. And I took some pictures and I was able to actually flip the board over and do all of these on the back side. And what's cool about that is the next time I do this, because I saved my picture where everything is, you can get to all of these connection points on this particular cluster without removing any of the needles. All you have to do is pull off the back panel of the cluster, which is super easy. It's like 4 clips. And if you know the connection points, you can connect right up to it, connect it to your programmer, and read and write in circuit on this particular application, right? I don't know all the vehicles that this was used in. There might be more early 2000 GMs where this is the case, but really, really easy connections if you know where they are. And I do now, which that's where this is beneficial. So anyways, I connect up. I'm able to read the new processor, the EEPROM section out of this one, which means I have a good connection to the module. I save the data just in case. You always want to save the data for anything that you read, just in case you need that file for one application or another. And then I take the file that I read, the EEPROM file out of the original one, and I punch that into the processor, and I powered up the module on the bench, and it came on and it read the correct mileage, 17,200 and some miles. So the EEPROM section for this processor on an 05 Buick Lacrosse has the mileage stored in it, but you can connect to the processor in order to do these read-write functions right through the backside of the board if you know where the connections are. And the Autel 608 will do all of these functions. I can confirm that. So this was a bit of a process. I was successful. It took me a lot of messing around to do this. I definitely would not say I was profitable on this job, right? I charged the guy fairly for what I did, but I had hours and hours into this thing. But it was a learning process, right? I almost consider it like an investment for the future. Now, how many 05 Buick Lacrosses am I going to deal with? Probably never see another one again, right? But now if somebody does call me on one of these, I can price this correctly. I know exactly what I need to do. And realistically, with the diagram that I have, I could probably have this all done in half an hour if I have all the parts in front of me. So next time I go around, all the time that I've invested with this one, it has the potential to pay off and be very profitable in the future. So it's one of those things, I'll take the hit on something in order to learn how to do it correctly, or whether I can do it or not too. I didn't even know for sure if this would work. And I felt pretty good when I saw that cluster light up and the mileage was correct. But the one other thing, I didn't change the flash section on this processor. There's a chance that you could potentially need to do that if the vehicle options are different. But this one, he was able to get one that was out of a, very similar Buick Lacrosse. And so we didn't need to change the flash. And so the EEPROM, again, is going to store the mileage, along with a few other things. I don't know exactly what all that is, but definitely the mileage, and that's transferred over with that read-write function. So pretty cool stuff. I find it super interesting, and it's been cool learning about that. So on to the next one. I've got a 2005 Nissan Altima. This is a crank no start. The shop called me and said it is a no-com, though. They said it cranks, it doesn't start, but it's also a no-com and the dash doesn't light up. Okay. So I get to the shop, check this thing out, and just like they said, the dash does not light up if you turn the key to the on position. It does crank, but the very first thing that I noticed about it cranking is that it was cranking really fast. Like this thing had little to no compression on any cylinder. So that kind of like tipped me off like, this thing's probably not starting because the timing's off. That was my very first thought. Is it sounded like a timing belt or chain that had jumped on this thing. Very little compression, just when that starter's going. But the dash didn't light up. And so I asked him, he's like, yeah, I heard that with the cranking too, but I couldn't talk to anything on my scan tool. Okay. Well, let me do what I'm here to do. They want to know about the no-com issue. I will address that. We'll see where we're at. We'll go from there. Right. But obviously I have it in the back of my mind, like, okay, this thing's probably out of time. So I connect up to it with scan tool and do an all system scan. I can actually talk to everything except for the instrument cluster. So I asked the tech again who was working on it. I was like, you couldn't talk to anything? He said, no, I can talk to anything on it. And I was like, well, let me see your scan tool. And we tried with a scan tool. So oddly enough, they have an autel. And I think something was up with the screen calibration because when he would press on Nissan, when he was selecting the vehicle, it actually pressed the make next to it and selected Toyota. And so when we were trying to talk to this thing, of course, it's not a Toyota and it didn't work. So that's why he couldn't talk to anything. So it was a scan tool error. But I did find with my scan tool, I think I was using the top down here, that I could talk to everything but the cluster, and the cluster's dead. And I said, do you want me to figure out what's going on in the cluster? I think there's another issue. He said, yeah, just figure out what's going on in the cluster. Okay. So I take a look at the diagram. It's a very simple setup. And the first thing I'm going to do here is check the fuses, right? Does it have power and ground to it? Very, very simple, basic checks anybody should do. So I do that. I go to the under dash fuse block. I find the cluster fuse. It's not there. There's just no fuse there. And I look up and I'm looking at the little schematic for the fuse box layout. And there's a fuse at the correct rating, 2 spots up where there's not supposed to be a fuse. And so I pull that out. There's not even any pins in where that fuse is. There's no electrical circuits because it's just a blank spot. And I move it down too. And then of course the cluster comes right on and I can talk to it. Okay. So somebody pulled the fuse out in attempts to do something and moved it to a different spot. I don't know. I tell you what, I've been finding so many vehicles lately with fuses that are just missing, just gone. It seems to be every other day I run into a car where there's just a missing fuse. So it's something I'm checking for all the time. People take them out and just don't put them back in or put them back in the wrong spot. I don't know. It's very interesting to me to why people would do that, even if, well, especially if they don't know anything about cars, but if you take something out, just put it back where it went. And I don't get it, but that's the way it is. So anyways, now the cluster works. So now I tell them, hey, this thing still doesn't start. And I knew it wouldn't because there's no compression. I'm like, do you want me to address this as well? Because it still doesn't start. They're like, well, yeah, that's why they brought it in. Okay. And I asked him about the fuse. He said he didn't move it. Maybe the customer did. I don't know. I don't care. The cluster works now and we don't have a communication issue. Now I just need to address, okay, let's just say this is a timing issue, and move on with my day. But I'm going to make my checks so that I can get paid correctly for the diagnosis. I'll have something to prove to the shop like, hey, this thing's out of time. Now, again, I'm listening to this thing crank. It sounds like there's no compression. This is the 2.5 liter. It's got a chain motor. So it's not like I can pop and check timing marks easily. I can do a cam crank waveform. That's one way. And there's another way that you can do a quick check for timing on Nissans. I didn't do it in this instance. I'll bring it up in a moment, what you could check. Or at least I didn't do this yet. But the first thing that I decided to do was a cam crank waveform. Reason being is they had the PCM hanging. It's behind the glove box on the passenger side. And he had been doing some checks on the network, I guess. And then he had the PCM exposed because he was thinking the no start was because the PCM was a no com because his tool was selecting Toyota instead of Nissan. And so anyways, hanging right there. And so all I got to do is connect to the circuits, cam and crank. There's just 2 of them on there's one, cam input, there's one crank input. That's it. So I do that. I easily find a known good for this particular vehicle, happens to be that the timing is dead on, right? I wanted to show them the diagram, like here's the timing. It's way off. You need to fix that. That's why this thing's not starting, but it was right on the money. Okay. Which I thought was odd. I was definitely expecting it to be off, and it wasn't. It was right where it needed to be. Okay. Well, that's strange. So I mentioned there's another check you can do on one of these Nissans to easily tell whether it's in time or not, or at least the cam crank signals are correct or not. Check for spark on these Nissans. If they are out of time by a certain amount, what they will do is they'll spark once. You'll get one spark from a coil, and then if you keep cranking, you won't get any more spark. Well, in this case, I kept getting spark. It kept sparking over and over again like it was trying to start. So everything I'm finding so far is this thing actually is in time. But again, just sounds like the starter's almost freewheeling on this thing. Just that sound of a timing belt jumping and things are moving, but there's no compression. I was like, well, that's definitely odd. What else would cause an entire engine to have little to no compression? Well, the other thing I'm thinking about is washed down cylinders, and it would have to be all four of them. But if all four of those cylinders were washed down, this could definitely happen. You could get a very low compression issue. And how would that happen? Maybe an excess of fuel, or maybe a scenario where there was no spark, and fuel is getting dumped into the cylinders and it eventually washed the oil down. Was this guy trying to crank over on this engine quite a bit to get it started? I think he was. But we potentially, again, have some washed down cylinder walls. So what I'm going to do here is, and I've already checked spark, so I'm going to pull out my spark plugs and I'm going to inspect the spark plugs, inspect down on the cylinder, and see what I've got there. Does it look like this engine's flooded? Now, I pulled the plugs out and they were dry, so it wasn't like they were completely full of fuel. I stuck a borescope down in the cylinder, and it's not what I would really call flooded. It definitely looked like there was more liquid in there than I would expect, but it's not like it was full of gas or anything like that. But here's the other thing that you can do if you're suspecting washdown cylinders. Well, I'd say one of the only things you can do if you're suspecting washdown cylinders is you can put a little bit of oil or transmission fluid down into the cylinders, crank this thing over, and see if your compression comes back or improves. So I do that, take a little bit of clean oil that they had at the shop, dump it in all four of the cylinders, put the plugs back in, and I just want to crank it and listen to it, and it did bump up. Now, I will say it didn't sound great. It didn't sound like real strong compression, but I actually did get some compression back on this thing when I put some oil down in there. So just confirming my suspicion that these cylinder walls are washed down. But my question is, why exactly is this the case? Now, again, what can cause this to happen? You can get an excess of fuel, maybe some bad fuel. That's a potential. I've seen vehicles that have, water in the fuel, something like that. Something that would cause it to get fuel sprayed into the cylinder, maybe too much, or maybe just not combusting. And then if you crank it enough, it's going to wash down the oil on those cylinder walls. Again, I'm thinking fuel at this point. I don't know exactly what. I did quick check injector pulse, and I actually may have done that earlier in the process, but I did have injector pulses. The injectors were trying to spray on this thing. But the one thing I hadn't done yet is check the fuel pressure and the quality, right? I've made it a point now, if I hook up to read fuel pressure on any vehicle now, I just get a sample. I bought a little graduated cylinder that I keep in my van, and I've just made it a point to always get a fuel sample from the thing, just to make sure that there's not water in the fuel. It's not E85 where it's not supposed to be. There's not a bunch of garbage, getting pumped up from the tank. Heck, I had one that it came out like black, and I don't even know what was in the tank or how it happened. But the engine wouldn't start. It was cranking over weird. Again, wash down cylinders and stuff on this one too. And the stuff I got out of the fuel tank it looked like mud. So I don't know if somebody would sabotage that one. But anyways, my point is I always get a fuel sample, and I hadn't done this on this vehicle yet, right? And I'm thinking fuel related. I don't know exactly what, but I'm going to check fuel pressure. On this one, it doesn't have a Schrader valve. So I popped a line off that's back by the firewall. Well, as it turns out, I had no fuel pressure in this thing at all. There was some gas in the lines, like it was dribbling out, but I had no fuel pressure. Okay, well, I can't get a fuel sample, and obviously the pressure is 0, so I think I'm onto something here. I could hear the pump running, though. When I'd cycle the pump or run it with my scan tool, I could hear the fuel pump in the back, and it sounded like it was, running at a normal fuel pump speed, but I wasn't getting any pressure. Now, I looked up at the gauge, okay, do we have gas in this thing? And it was just above E on the fuel gauge, right? So you got the bottom bar and the gauge was just slightly above it. So I don't know, maybe a 16th of a tank, but it wasn't completely empty, at least what the gauge said. But now I'm considering, well, is this gauge accurate, or is the sending unit accurate in the fuel tank? Is this thing actually out of gas? Because I can hear the pump running. I got a little bit of fuel in the lines, but it's not building up any pressure. How do I check this? This is one where we can do an amp clamp right around the feed to the fuel pump and run that pump, and we can see what the amperage is and we can see what the RPM is. Now the RPM, you kind of have to have a known good in order to really utilize this as far as a spec, but you can get an idea and you can combine it with the amperage. What is the fuse rating for the circuit and what is the pump actually running at? Right? We're not moving any fluid. In this case, it was only pulling about 2 amps. It was spinning. The commutator sections looked pretty good, and it was running about 8,000 RPM. So I think that's a little fast. I think usually, and again, it really depends on the pump, because I've seen ones that run at 9 and they're fine, and that's normal. But a lot of pumps, they'll run closer to 6,000 RPM. And this one was running 8, again, 2 amps, which I'm looking at is pretty low amperage here. So we have a fast moving pump with low amperage, means that it's just freewheeling. It's not pushing anything. It's probably out of gas. Now, maybe the impeller's broken on the pump, maybe, but given where the tank is at, just above E, and the situation we have, this looks like a no gas situation. Okay. So I tell the shop, hey, this thing's out of gas. The sending unit is reading incorrectly. I fixed your cluster issue with moving the fuse. Now you do have still some wash down cylinders a little bit. I improved it with the oil a little bit, but you're going to have to get this thing started and then change the oil on it as well. Now, the one last question was like, well, how did those cylinder walls get washed down, especially if it ran out of gas? And here's my guess, and this is just a guess that I have. I think it's fairly accurate, but when this thing stalled, when it ran out of gas, the customer continued to keep trying cranking and cranking and cranking and cranking, and probably, I don't know, moved a fuse around at the same time, but he kept cranking and cranking with this thing. And as he was cranking it, the injectors were still spraying, right? They were turning on, spraying what fuel was actually in the rail, not pressurized, but dribbling fuel out into these cylinders, right? Now, I know from personal experience that this can wash down cylinder walls. Where have I experienced this before? At the college, we do a section where we do compression testing on engines. So we use the school cars, we use student vehicles, and I have them test every single cylinder on an engine, right? So when I first started doing this, I told them disable the fuel so that we can do, these cranking tests, this cranking compression tests on the cylinder, and we can do all the cylinders. And they would do that, and I wasn't specific enough, so they would just unplug the fuel pump relay or unplug the fuel pump. The problem there is, during the testing, as you're going through each cylinder, doing compression checks on each one, the injectors are still spraying. Even though there's no pressure, it's putting fuel into the cylinder. And I watched it on their results. By the time they got to the last cylinder, they were at very, very low compression. They were getting like 50 or 60 PSI on the last cylinder on a known good engine with no problems, because the fuel that had been just dribbling in there was enough to wash the oil down the cylinder walls. And my guess is with this Nissan that's what happened. Doing a little bit of reading on Identifix, I did see that these particular engines, I guess, are very susceptible to flooding. This is not the first time this has happened on one of those. But anyways, this thing needs gas, potentially a sending unit if they want to correct the inaccurate gas gauge, which is what caused this thing to stall in the first place. And then an oil change and I don't know, maybe some spark plugs, but that's going to fix this one. So ran out of gas, but caused a series of other events that we had to work through in order to get to the solution. So pretty interesting stuff. That's my 3 case studies for this week. I appreciate you listening. Hopefully you found all that interesting. But other than that, Let's get out there, start fixing the world one car at a time.